Alright, so now let us talk about sector area. So you will notice below the title sector area, I wrote this question, right? What is sector? What is segment? As a reminder to myself, right, to talk about sector as well as segment before proceeding to show you the formula for sector area. Now, for sector, we have talked about what it is a little when we are talking about arc length. So over here, this will be a quick recap. So, what is sector? So drawing a circle, let me show you what a sector is. And sector is actually this, what I always like to call it, pizza slice. So imagine you have a pizza over here, right? If you cut the pizza from the center of the pizza and then make such a slice, right? This will be, let me put it in red. This will be your uh, sector, right? So where the red color is actually, I believe previously in other videos I use blue. So let's keep it consistent. So the blue is actually your minor sector, while the red one is this thing called your major sector. All right, this is the major sector. Now, so that's sector itself. So think of it as your pizza slice, your birthday cake slices, right? So that is um, how sector looks like. Contrast that to segment. Segment itself is if you cut a circle from one end of the circumference to the other end of the circumference without passing through the center of the circle. All right. So this over here, the blue one, is actually going to be your minor segment. So this is your minor segment, while the red is your major segment. So this is your major segment. So I always tell my students that if you can think of sector as pizza slices, then segment is the way that you would never want your pizza to be cut, right? Unless you're taking the major part, so you will have more to eat. But it's like uh, anyhow cutting the pizza, right? And then just going across the whole slice. Uh, yeah, so um, that is how you can visualize and differentiate sector from segment. So over here, we'll be talking about sector area. And in fact, you may notice that even for arc length, that arc length itself is referring to the circumference or portion of circumference for a sector. So both arc length, sector area, these are all used for sectors. As for segment, well, it's good to learn about what they are, but the formula for arc length as well as sector area will not be applied to the segment. All right. So with that, we can go on to the formula for finding sector area, right? So much like the arc length, um, and where I say much like it, I mean for arc length, right? You are finding a portion of the circumference. So for sector area, actually what we are finding here is a portion of the area of circle. So um, previously, if you follow my analogy, right, on this minor sector, the arc length is actually this portion, which is the portion of a circumference. And the analogy I used was like finding the crust, right? So that is the crust of the pizza. Now, for sector area, the way you can imagine it, that is actually the meat of the pizza, the whole pizza itself, right? So sector area, as area is always the region that is in the center, right? Or the region that covers uh, a particular inner the which is the inner region of a shape, right? So the inner region of this minus sector is actually the one that will be referred to when we are calculating sector area. Now, so formula wise, we will be using the formula for calculating area of circle. So you will be familiar, that is your pi, let me write it a bit smaller, maybe here, pi r square. All right, so finding the area of circle, that is pi r square. And since we are finding a pizza slice, right, we need a portion of it. So very similar idea to arc length. We'll go ahead and find out what is the portion of it. So say if you have a semicircle, right, if you want to find the area, this will be half, right? If you have a quarter of a circle, you put 1/4. The problem here is that you don't know how how much of a portion this slice is, right? This minor sector is. If I tell you this is 1/6, you put 1/6, right? So over here, what they give you is actually angle. So let's use 60 degrees again, right? So they may tell you that this angle is actually 60 degrees. And what we will do is that to find the formula or to find the sector area, we will put in the proportion, which is 60 over 360. All right, and then just putting into the calculator, you will get the value for the sector area. And the formula for radian is very similar, just that instead of the proportion in degree, right, you put it in terms of radian. So pi r square times the particular radian. So let's say instead of it being 60 degrees, it's actually 1.2 radian over here. What we'll do is we'll put 1.2 over 2 pi, right, where 2 pi is the whole angle for the circle. So for a circle, right, angle or based on your angles of the point, that in degree it will be 360, in radian it will be 2 pi. All right, so at this stage, I can address the formula for finding sector area when your angle is in radian as well, right? What am I talking about? Is this half uh, r square theta. So some teachers will tell you to memorize the formula for finding sector area is actually half r square theta, right? And over here, let me show it to you first, how to derive this. So the way to derive this is actually from your formula for radian. So over here, let's try to simplify this formula. And you can think of pi r square as this is just number, right? So if you realize pi is 3.142, so on and so forth with some more numbers behind, and then your radius could be whatever number that they want you to find. But regardless, after you multiply, your whole pi r square is going to be a number. So I can treat this as it's a number over 1, right? Because these are going to be uh, numbers, not a fraction. So with that, I can actually simplify it by multiplying 1.2 over 2 pi. Sorry, my bad, not 1.2, theta. So over here, uh, because theta is the angle that we'll be using, so using this is a general formula for finding sector area, right? So that's why I use theta instead of putting in the specific angle of 1.2. Now, you can cancel the pi away, and then what you will realize is that you have a r square on top over here, as well as theta on top over here. So a fraction multiplied by a fraction, um, your top or your numerator will multiply with the numerator, so top times top. Bottom will multiply with bottom, so denominator multiply with denominator. So you get r square theta over 2. And if you simplify it a little, bring out the 1 over 2, you have r square theta being left, right? So this is the formula or the proof for half r square theta. And similar to what I've said in arc length, this formula can only be used if your angle is in radian. So that means if your angle is in degree, you cannot use this formula. So which is why I don't like to teach my students this. I would much prefer to have my students know that if I'm finding sector area, it is a portion of the area. So use the formula for area of a circle, pi r square, and then calculate what's the portion, be it in radian or in degree. Okay, so if you can understand this, we will go on to talk about this example over here in the next video. So try out first and see whether you can apply the sector area formula, and I'll see you in the next video.